AI students informed. AI students. Class will be held in 207.
Yes,
Sir.
sir. Yes, sir. Yeah.
Message will go. Yes, sir.
Hurry up, please. Hurry up. Okay, I think I should start the class. Students who are getting late, I cannot ask if you must come. This, okay, last day you watched, okay, whatever the stuff is basically following the AI consideration. Many times decisions, okay, has been made depending upon the prior information. But sometimes decision has been made suddenly, okay, without the prior information, prior data. So once you are making the decisions, there are certain approaches. If we see in these approaches, what we are doing, basically we are bridging the gap between the problems and how to tackle the problems, okay. So of course, with the advent of advanced technology, we are using the programming or somehow any tools so that with the help of computations, problems can be computed very fastly and with better accuracy as well. For example, in this case of car parking systems, if you will design or you will develop some kind of a mechanism, okay, so that incoming cars, outgoing cars, and location of cars, each and everything can be tracked with the help of computing or AI power, then of course the system will much useful and amicable for the human. So everything in AI is help out to make the system easy and robust. Robust means that reliable and some kind of a much, okay, trustworthy. In this, first of all, we need to develop some kind of a model. So modeling is an important thing. In this modeling, you need to think. And for thinking, you need to have some knowledge, experiences of the life. Okay? So because you can notice the child cannot decide better than, okay, or very, okay, you can say, because little experience. Especially you can notice the many students are at the young age driving the motorbikes and facing the accidents, but the old person is driving with huge experience, so less okay, accidents are occurred. So everything depends upon the models, okay, models that where we need to go, how we will go, all the things are depending in the situations. In this, you need to focus the inference the path, okay. For example, you want to reach from point A to point B, okay, then you will think about the shortest possible path, or maybe sometimes not the shortest possible path, so you can say that the reliable path, safe path. For example, you want to travel from this area, okay, Haripur to capital of Pakistan, Islamabad, there are certain routes, motorway, okay, the Hanpur, okay, according to your time or you maybe the cost or maybe sightseeing, you will decide one possible route, okay. So inference, and this inference also consider the terms learning. Because you familiar, you learned something, okay, while you traveled via motorway, you also learned something while you traveled via Hanpur road, okay, so the things are important in case of learning, then of course inference will be set and your model of course will consider both the things. In this situation, we can say we need to develop some kind of a paradigm and the real world problems will, okay, further, okay, can be noticed. For example, in case of a car parking system, you want to, okay, set some kind of a input, incoming of the cars, outgoing of the cars, so you will develop some kind of a complete model, inference, okay, or with and the learning mechanism. So once there is no inference, then of course you are blind. In case, because you don't have learned anything, because for example route is the newest one, you are traveling from one point A to point B, you did not learn, you cannot, okay, decide, no inference, okay, you, because no information, this information can be done, okay, via Google Map, whatsoever, but if you are going first time or maybe even without using the Google Map, the thing will really complicated for you. So in this situation, okay, before considering the shortest way or shortest possible route, you are learning. Once you are learning, you are keeping the data. So data is important thing in this situation. So data is gathering, collecting, and that's why we say huge number of data, huge precision and accuracy. Less data, less accuracy, precision and accuracy. So learning, okay, we collect huge amount of data, then of course we can say that we are emphasizing. For example, we love the sightseeing, beautiful sightseeing, or the water serenity. We can say that the Hanpur Dam is a good, because parameters, okay, parameters involved. For example, water, okay, if we love the Hanpur Dam kind of thing, or the stuff, the greenery, okay, fruit, gardens kind of stuff. So of course, the parameters weight is huge on this side. But on the motorway, you will say that the road is really smooth and no obstruction of the traffic, so of course you will follow the motorway. So important thing in this paradigm of learning, you are collecting the data with certain, okay, parameters. You are in parameters, or you can say that the values of interest. And sometimes you don't think like this, okay? You need plan and move. For example, this kind of a game. Are you getting my point?
Yes, sir.
So parameters, okay, kind of a Hanpur Dam, okay, so value of interest are changing here. You cannot say, okay, that you have some prior data kind of, though you have to know the playing techniques. But if some other opponents move in different way, okay, then abruptly, suddenly, you will change your move. Are you getting the point?
Yes.
So plan and move. In this situation, you will, there are certain state-based models, kind of a chess. Maybe some of you very much genius in playing of chess, but some of me like, okay, so I say very much new in this game. So of course, certain planning is required to move further. In this situation, state-based models, we can say that okay, kind of a chess games or Pac-Man. Hopefully today in the lab you will consider this stuff, or robotics, motion planning, or natural language processing, translations, image processing, computer vision, recognition, detection, segmentation, whatsoever. There are certain things in the state-based models. First, okay, in modeling is required where inference and the learnings play their role, but sometimes state-based models you need to plan and move. So there are different statistic approaches are used. First one, okay, is kind of a here. These are the certain problems. These are very easy problem. Okay, you can control each and everything. You don't depend upon others. Search, okay, based problems. For example, you are hungry, you will find some fruit or some eating material, you will eat. That's simple thing. So sometimes, for example, there is a Markov decision process. I will explain this. You don't know this is the A, this is the B, or you don't know which one is better. And sometimes, okay, adversarial games, kind of a chess, you need to plan and move. You are observing the opponent's tricks, okay, then you will plan to tackle which one. Both the things are the first one, this one is the, you don't know. You don't know, okay? You are totally almost blind. For example, in a Ludo game, you can see, notice the dice. Okay, you don't know, you will get a 6 or you will get a 1, you don't know.
Yes, sir.
But in this case, in chess games, you know, according to the situations. So, these are the adversarial games. Okay, now there are the state-based models, there are 3 situations. Mostly AI follow these situations. And if we go a little bit further, this is a very well known, okay, Stuco game. I will give you assignment today also. So this one is the 3 by 3 matrix. You can model. You need to fill, for example, this one column or one row from 1 to 9. So this is another, okay, kind of a trick, but I think I will assign you a task and you will see it later. So I was talking about the constraint model kind of, for example, in the scheduling, okay, Stuco. Of course, this is some kind of a searching game, searching things. You need to search among different things. For example, this one is a position A. You want to reach position 4. You can follow this track also, you can follow this track also. There are 2 possible tracks. But though the distance is same, it depends upon the situation why you want to choose this one or why you don't want to choose the F2, okay, this path to reach some destinations. So kind of a, okay, Sudoku problem. So hard constraints are involved, but it's not, okay, too difficult. This one, very much tricky. All of your mobile phones, all of your wonderful gadgets, all of the AI systems follow the Bayesian networks. Last day, one of our brilliant students, Rehab, is sitting here. She demonstrated very well, she presented about the Bayesian. So what's the Bayesian basically? For example, these are the, okay, location of the cars in the parking system. These are the sensors, E1, E2, E3, E4, E5. Sense the location of each car. So how they work? They will follow some kind of a network, Bayesian network. Usually last year they have told us in this way kind of a formulae, okay. So they, basically you will notice many textbook notions. A and B, what are basically? These are the kind of a variables. Okay, sometimes they are using in this summation, but for the simplicity, I would like to explain from here. This, okay, H, you can say represent the prior information. Prior. And E represents some kind of evidence. So if you are at this position, then you want to get, okay, deduce. You want to, okay, make a concept from the prior, okay, given of the evidence. Using the prior with evidence, you will define or you will design some sense to move further. So here, probability of this, again here, the evidence given, okay, from where? Prior. I will explain this, okay. So this one is the totally prior, and this one is the probability of totally evidence. So let me explain it, how it's going. For example, we are talking about houses and its prices. So you want to buy some house, of course the evidence is this house is, okay, should have some bathroom, should have some kitchens, should have some rooms, then you will say it's a house. If there is only one room, no kitchen, no bathroom, then you will not say it's a house. Though it's kind of a building or one room kind of a shop, but it's not a house. Evidence of a house should fulfill the basic criteria at least. This is clear about the house? Yes. Okay, let's talk about the prior information. House is constructed on some land. The house cannot be constructed in here. There should be some land, solid land, some space. This thing, at least this thing should be there. Of course, once there is a land, okay, of course it will have some price value. If it's in a very far-flung town, then price value will, of course, definitely not very high, but in capital area, price will very high. So that is the prior information to belong to that house. So evidence, the, okay, constructed area somehow, whatever you can see, observe. Now this is the probability of evidence, okay, you are observing some land, okay, and house constructed on it, this is. However, once you have the visiting too many houses, because you are going to buy some beautiful house according to your needs and demand whatsoever, interest. So maybe you will observe one house, another house, too many, all number of evidences you are collecting regarding the houses. So above one is clear. Then you will, this is your, okay, final thing. You will say that you observed the 10 houses. Among 10 houses, you said that this one is the more, okay, near to my heart. I want to buy it. Then of course you will set it, you will pay its price according to the prior land value, okay? So evidence is, you will, okay, generalize, you noticed all the 10 houses, you will divide by it. So among 10 houses. And this thing is this one is the, okay, you are currently noticing. So you will see that this house price should be look like this. However, what will happen if this one is the price of a land, it is updating, for example, due to, okay, some dollar value, okay, in some market. Before, previously, okay, last year price was $10 10 lakh per marla, now it is updating and become 15 lakh per marla. So what will happen? All this, okay, evidence, you know, the price will be updated. So this will be updated. Though nowadays house prices are increasing exponentially. So your machine, okay, AI work like this automatically, observing the prior or each and everything and then updating its, okay, decision according to the time. So whatever you are, for example, mobile phones is collecting some kind of a pictures, data, is updating the number of images in it, whatsoever, data bank is, okay, developing. So your chats, WhatsApp, everything, your emails, junk values, some saturated, so no enough space in the hard disk. Okay, are you getting the point? So Bayesian, very much important. And credit goes to Rehab, our data student who told us about this last thing. Thank you, my daughter. Yeah. Yes. If you people will not show some interest, then I can not able to teach you anything.
Yes, sir.
So, it's clear about the Bayesian stuff?
Yes, sir.
Thank you. Let's move a little bit further. Okay, this is some kind of an example. If cancer corresponds to one age, then by using the Bayes theorem, we can determine the probability of cancer more accurately with the help of age. For example, at the age of 18 years, someone is having a tumor cell, cancer cell, okay, so it will grow, okay, we know after, when at the age of 19, 20, it will increase, okay. So if someone say that at the age of 50 years, you can see that the updating, are you getting the, I told you the last, in Bayesian updating, okay.
Yes, sir.
So in this body, this cancer, after, that's why doctor said that after 2 years, after 3 months, you will become dead. Okay, you will not, you will be expired.
Yes, sir.
Clinical language, expired. Okay, respect for everyone. I'm also near to expiry age, but are you getting the situation? So Bayesian updates. If someone is very healthy, prior information, P of X, probability of prior, very healthy, maybe, okay, doctor says that it will take more time, but like me, okay, yeah, very soon, very short time to live. Are you getting the situation?
Yes, sir.
If we say the another beautiful thing, that is the Markovian, where we don't have prior information, we don't use the prior information, we need to decide at once.
Yes, sir.
Certain decision. In last day movie you watch Martian, somewhere many times he used the knife to thrust, okay, him upself. So Markovian. Are you getting the point?
Yes.
So in this situation, yeah, if the conditional probability distribution of future states only depend upon the current state, not the prior, not the past history. Okay, current state, then it will work, okay. If you say like more, okay, you can see that the actions and motivation you can notice in the Markov decision process, that at each step during the process, the decision maker may choose to take an action available in the current state. For example, if I want to write, I can use my finger, I can use this stylus. At the moment, I have these two options for writing purpose. Okay? Maybe I can say that this one is much more good, okay? So, Markov decision process. So, current state, resulting in the model moving to the next step and offering the decision maker a reward. Because why I use this one? Easy, better, okay? Efficiency is good. If I will use my finger like this, then of course it will work. But not, I will have a better control on it.
Yes, sir.
This is kind of a reward, better control.
Yes. Yes.
Are you getting my children or not?
Yes.
Yeah. Who will prepare the Markov decision process for presenting? Okay, will you please? Next class?
Yes.
Yeah, Markov decision process. Okay, lot of okay. You will have good. No one from AI. You will get ready to become fail. Okay. What is your name? Umar. And what is your name? Yeah. Okay. Clapping for both. This will be a decision. Both will prepare the Markov decision presentation on Markov decision process. This will kind of a decision, and they will get a reward. Okay.
Inshallah.
Is it okay?
Yes,
Happy?
sir.
In the next class, we will merge, okay, and you both will try to prepare very wonderfully with real life examples, concrete descriptions, okay? So make it interesting as much as you can. Okay? Yeah, 2 class competition. Thank you so much. So, as we start talking about the Markov, okay? So, agent, what do action, of course, he gets some, okay, existing state environment, okay, I have this one, I can use the finger, so I am using, okay, according to the reward basis, I am using the
सर
GS, please, sorry.
प्रीवियस एक्सपीरियंस इसमें शामिल होता
No, I say that, sir, how do you know that using this stylus is good or the pen, using the finger? No, at the moment. Okay, I have these 2 options. Okay, I have these 2 options. But even, yeah, what good, okay? But so for example, in the cricket match, 2 bowlers, so you little bit, little knowledge everywhere. But in calculation, we are not using it because for the robotics. Yes, please.
सर इसमें हमारा previous experience depend करता है ना एक experienced person है वो अगर current state के साथ
But a competition, robots, okay, robots, whatever you will feed to the robot, okay, data, of course, data. Here you can say data.
प्रीवियस डेटा तो कंप्यूट करेंगे
Yeah, of course, data is a huge amount of data, but the situation is this. You are not utilizing this data in particular set of action because the action is a new thing. Markov decision process, new, okay, for example, I am a new teacher, I never used this stylus pen, I never used, okay, finger, okay. Then in this case, Markov decision process, application. Are you getting my point?
Yes, sir.
Because okay, sir, you can write, I am a new teacher in your class, you can say, sir, you can use your finger as well, you can use this stylus. So, being a teacher, I will decide
Yes, sir.
abruptly, I don't have any experience. But I will say, action, oh yeah, if this thing is extra, okay, why should I use the finger? Then maybe I will get, okay, are you getting the point?
Yes, sir.
Yes.
Reward automatically will be provided to me. Certain decision.
Yes.
Yeah, more Umar and this all the queries will be cleared by our 2 gentlemen, inshallah. Hopefully you will enjoy a lot. Okay? Inshallah. So, assignment please. Note down assignment. All of you. First assignment. One is a search problem. State-based models. Sudoku, okay, come on, okay, you don't use your, at least you should. So on these 3 topics, you will write